My name is Roland van Rosenveld. I'm a 68-year-old architect from Cape Town, South Africa. I'd always had a keen interest in the pyramids since I was 10 years old. And earlier this year, I was very privileged to go on a grand tour of Egypt with renowned author Graham Hancock. It was a bucket list item that I'd never really accomplished. And when I embarked on this trip, I had no specific goals in mind. I was going to visit the temples, to look at the pyramids, and just enjoy a 2-week period in ancient Egypt. And to be guided by Graham, I went there and some things happened that I didn't expect to happen. For about a month beforehand, I gathered information off the internet and out of various books and compiled a journal to take with me that I could refer to on a daily basis to whichever monument or pyramid we were going to visit. And that formed the basis of what I knew about Egypt and the temples, pyramids, etc. before I left. I'm not an expert on them at all. And the first pyramid that I went to was the stepped pyramid at Saqqara, Zoser's pyramid. And we descended down to the bottom part of the pyramid where the sarcophagus was housed. And I looked up and I immediately felt that I knew how they built the pyramids. When I looked up, what I saw from an architectural point of view was a lift shaft. A lift shaft that you'd find on any contemporary construction site. And immediately I thought, well, the way they lifted the blocks must have been through a hoist, in a shaft, and a counterweight. That seems to be the only efficient way of actually building these pyramids and moving millions of blocks. And that evening I went back to the hotel and I spent some time sketching what I thought or how I thought this might manifest itself and what mechanism would be required. And what I came up with was a very quick little sketch. So the way it would work is that there'd be a central shaft, very much like a lift shaft, that there would be some manner, a tunnel of some sort that the blocks would be able to be brought to a loading station where they'd be attached to a rope. The counterweight would drop down and the block would be raised up to whatever level is required. Now, it's a very conceptual sketch and it had not been thought through in any way, but I needed to put down a first approximation in order to have something down on paper that I could refer to. And it reminded me a lot of the mine dumps that we have on the Witwatersrand in South Africa, where they have these pulley systems and they have the lifts and hoists going up and down, taking the miners down to mine the gold. I thought that probably what I should do is take the most difficult example, to take the Great Pyramid and to have a look at how my theory could work within the Great Pyramid, within what exists there, and where I might find a shaft or two that I could use for the counterweight to go down and to lift the blocks. I'm going to do sketches while I am on this tour. I'm in the main chamber, and the theory that I worked on last night, there's like evidence right here of some poles at the very top. There's one that goes right across. That's obviously, yeah, it's just, I cannot believe. There's some that are, I don't know where that one's going to, but and then there's some ones that are cut off. The thing was, I only went into the Great Pyramid on the last day of the tour. About to enter the Great Pyramid. Been waiting for this my whole life. Just flipping awesome. Absolutely awesome.
Watch your steps.
So everything that I'd been working on then was either stuff that was in my head already, but I hadn't experienced it yet. But I still thought I would continue with the theory, and hopefully I would come up with something by the time I visited them, or by the time I visited the Great Pyramid, and that's where it all started for me. So this was one of the very first sketches I did, and this sketch I was trying to find out where suitable locations might be to establish a hoist, where it would probably work best, and these positions that I've drawn here were to me the most likely and most efficient positions to construct a hoisting shaft. I went onto the internet and I downloaded a section, not a detailed section, but a section showing all the components, the existing components within the pyramid, which included the descending corridor, subterranean chamber, Queen's chamber, ascending corridor, grand gallery, and the King's chamber. And what I wanted to do was look at how these components could have been served by a shaft, by a hoisting mechanism within the shaft. And that's where I started my process of looking at each of the components of the existing pyramid and questioning, why are they there? Why are they placed in the positions they are? And how come they're dead-end corridors, etc. So I'll go in a little more detail closer up on there, and then we can have a look at where I'm coming from with these thoughts. When I got back from Egypt, I was so inspired by this theory and wanting to explain it or test it in a more professional architectural fashion. And I started drawing immediately I got back. And I worked for about 6 weeks doing drawing work. I would work till 4 o'clock in the morning, have 2 hours sleep, and then start the next day. But I wasn't tired. I was just so inspired. I could not wait to carry on working. So I'll show you the drawings now, and we can run through them and see where I'm at. Okay, I started the drawing process, and I worked on 3-dimensional drawings plus a cross-section to go up at each phase of the pyramid construction. And the drawings are not to scale, but are illustrations that help a layman understand the construction process and how the various components are linked together. I think it's far easier to understand and to visualize when you've got a couple of people pulling sledges with limestone blocks on, and you can see people excavating and moving stuff out of these corridors. So to me, it made sense. It's easy to understand, and you can follow the progression of the pyramid in the 3-dimensional drawing. Furthermore, one thing that I kind of failed to understand is that why use computer-generated imaging, AI, to solve a problem that was 4,500 years ago when they didn't have that technology at the time. If you want a realistic solution, use the tools that they had at the time those pyramids were built. To me, it just kind of makes sense. And that's why I did everything by hand, because most people don't approach it like this. They approach it with computer-generated drawings. And those are easy to change. If you change your mind, halfway through you decide to put the ramp on the outside or you decide to put it on the inside, it's very easy to change it on computer. When you're drawing by hand, every line you put down, you have to rub out, and particularly on this type of paper, you tear the page. So that's how I got to drawing by hand. I must assume that the architect for the Great Pyramid would have produced drawings, both plan drawings and cross-sectional drawings, in order to establish exactly where the King's Chamber, the ascending corridor, Grand Gallery, etc. was going to be. So when, and this is based on my theory that there was the shaft, they would have known the position of that shaft. They would have been able to set out that position. And once you've got the perimeter set out, take the diagonals across and you will find the apex point of the pyramid. And there would have been a staff placed in the ground to mark the apex point. From that point on, they would have established the true north position. One of the fundamental principles of the Great Pyramid is that it faces within millimeters of degrees true north. And the question is, well, how did they establish true north? That would have been done by a pole stuck in the ground vertically, and the shadows of that top of the pole would have been plotted when the sun rises in the east, at any time there, as long as it's on the east, and when the sun sets in the west, you take another spot and you mark those two spots. You join the two lines, and you take a perpendicular line to those two, and that gives you true north based on the sun. Then they would have used 3, 4, 5 triangles in order to ensure that they got 90 degrees, and the first few courses of blocks would have been dragged in on sleighs, and they would have placed it on the perimeter for the start. And that apex point you would have to keep moving up every course with a plumb bob to ensure that when you get to the top, you're actually getting the correct geometry and you don't end up with the apex sticking out the side somewhere and the pyramid being lopsided. They would have started excavating the shaft that I proposed from the ground level and working down towards the subterranean chamber and this little dead-end corridor. I've produced a section over here where I show the excavation of the shaft and excavation of the descending corridor. And the one thing that I realized with respect to the hoisting shaft is that the lower coursing of blockworks on the Great Pyramid, probably the first 10 courses, were made out of much larger limestone blocks than those above. So generally what it is at about the level of the Queen's Chamber floor is where the block started getting smaller as the pyramid converged. But certainly the lower blocks were all very heavy and may not have been that efficiently moved by the hoist, but I propose that the lower ones were actually done via ramps, as I've indicated here. People dragging the blocks up the ramp, and I think most theories do include a certain amount of use of ramps for particularly those lower courses. All right, so this is the next three-dimensional drawing in the phasing, and it shows a 7-degree ramp. It is diagrammatic, it is not to scale, it's indicative. At ground level, there would have been a tunnel that led to a loading chamber, which is probably easier reflected just across here. The limestone blocks would be dragged on sleighs into this area, and here we would load the blocks onto the lifting hoist, and here would be the counterweight of stones filled in a sail or a box full of stones or whatever other counterweight they might have, and the counterweight would drop down and the stone would lift up, and there would be guys at that level who would hook the rope and bring the stone across, and then it would be dragged off and positioned as one other course. The material excavated from the shaft would then be stored and be used as counterweights later in the program. This is just a little three-dimensional sketch of what I presumed the pit of the King's Chamber shaft to look like. The labor would have come out of the subterranean chamber, crawled through what is called the blind corridor, and they would have been able to access the pit of the shaft at that point. We're at the next phase of construction, and this little pyramid roof here, you see all this double pitch roof here is actually the Queen's Chamber. So we're kind of at the floor level of the Queen's Chamber in this. What we have here is the Grand Gallery, and the King's Chamber would be above there. The ascending corridor, descending corridor, subterranean chamber, and the bottom of the hoisting shaft. Here's some excavation still in the pit of the shaft, which, as I said before, would have been accessed via the descending corridor through the subterranean, through the dead-end corridor, into the pit of the shaft. Limestone blocks being dragged into the loading area at ground floor, where the blocks would have been coming in. They would be loaded up here onto a hoist, onto the platform they use as the hoist, and then the counterweight balance would be loaded here, drop down, and the block would be raised up. One of the things that's also bothered me tremendously about the various theories that have been put forward is that none of them seem to adequately address how they check dimensional accuracy at every course level. Because the pyramid ended up to be a very accurate structure, when it was cased in the Tura limestones at the end, it was a perfect structure. And in order to maintain that dimensional accuracy, there had to be checks in place. And unless you have a flat surface, I would find it extremely difficult to find a way to check the dimensional accuracy. So this model is kind of just looking at a phase in the building of the pyramid and saying, we have, over here we'd have the apex pole, which is something that we would have to maintain at every level. We will bring the apex pole up, so we always know where the apex of the pyramid is going to end up. Secondly, that apex pole would have been used to draw a piece of rope from the apex pole to each of the corners. And you'd have a knot tied in the rope, and you would check that all your corners are equidistant from the apex pole. It has to be done that way. There's no GPS, there's no theodolites, there's no survey equipment, and I fail to understand how it could be done any other way other than with these basic tools. But that's in principle how it works. On the ramp side, I think on the hoisting side, it's pretty basic. It's the rope strung over a cedar tree trunk, and you've got the counterweight the one side, and you've got the limestone block the other side, and that should work pretty easily there. I think that's self-explanatory. Again, I'm just going to refer to a sketch that I did while I was in Egypt, and what this is showing is an offloading platform as the pyramid grows upward each course. And what I've shown here is a timber axle, probably a cedar wood tree trunk from Lebanon, that's built into side walls, a rope that's attached to the block that's being lifted, and the counterweight that's dropping down the shaft. And I think what I wanted to point out in here is that there was a hooked end that was found, a copper hooked end that was found on the pyramid site. I believe that it's in the British Museum. And I'm saying what that was used for, it would have been put on the end of a pole, and it would have been used to hook the rope out of the middle of the shaft. I can't think of any other purpose for that thing. And, you know, I just feel it kind of almost reinforces the idea that there was a vertical shaft and you needed that tool to hook the rope. And that's what this drawing talks to. One of the things I did want to mention is that there have been a lot written about the Egyptians being magicians of gravity, and I think that came from an anonymous author who wrote the book The Pyramid Code. And I've also read something about priests chanting and the blocks being levitated by sound, and I think that might have been misinterpreted and probably could have just meant that, you know, people were not used to seeing things being hoisted by gravity, and it would appear like these stones are levitating by themselves as they move up the shaft. And the kind of chanting could well have been, okay, lift, oh no, stop, lower, and wasn't necessarily spiritual chanting. It was more instructions about how we were going to lift and lower these blocks. At the start of any construction or large construction site, one of the first decisions that the contractor has to make is where he's going to place his crane. Because the position of the crane, well, it's determined by where the materials arrive, the reach of the jib, etc. And if we were to construct the pyramids out of blocks today, the most likely solution would be they would have used a crane in contemporary construction site. And what I'm saying is the vertical shaft has replaced the crane in the Great Pyramid. That's how they constructed it. This drawing here is essentially a duplicate of the previous drawing that was on the drawing board, but what it does include is an extension of the roof of the Grand Gallery outward to create a ramp. And that ramp would be used most likely to hold up the huge beams at the relieving chamber on top of the king's chamber. Those were apparently sort of 70-ton beams, and it's unlikely that they would have been able to be lifted in the shaft itself. The shaft would have been just for the lighter sort of 2-ton blocks, but the heavy beams would have to have been dragged up that ramp. As I've said earlier on, this is not to scale. When I referred back to scale at the end of this video, you will see that that ramp, if it's extended, does not exceed the perimeter of the pyramid itself. But in this drawing, it just happens to go like that because it wasn't to scale, but all it is a diagrammatic thing showing that the blocks could be hauled up the 26-degree ramp made by an extension of the Grand Gallery roof and using the shaft as the counterweight to assist the moving of that. We're just looking in this model at how the ramp might work to bring the main relieving chamber 70-ton beams up the ramp. So we're using the counterweight King's Chamber shaft. We've got a ramp here, which is the extension of the Grand Gallery. I'm busy holding this 70-ton beam back, and I'm going to release it now. Coming up here, counterweight, maybe there's some labor helping, but most of the work has been done by the counterweight system, and here we have one of the beams arriving at the correct level. Another thing just to consider with this proposed ramp is there does seem to be some kind of convergence of technologies, because when I look at pictures of the Peruvian pyramids. They've got these sort of staircases that lead to them, and it's not dissimilar to having a ramp over there and having a ramp on the outside to draw up the materials to the top, and they might possibly have used a very similar kind of system in there with counterweights to bring the materials up to that level. Okay, the next drawing I have is what I call, is like a composite drawing. It shows various phases at once. I've specifically omitted the grand gallery out of the drawing simply because I wanted some transparency to see what's been happening on the other side. I think there was a point when the king's chamber had been built and the relieving chambers were built that the shaft, or my proposed solution is that the shaft was then moved across so that it would be more aligned with the apex. So ultimately, when the shaft reduced in size as it got to the top, you were left with a very small plan shape that you had to put blocks on that became manageable. Everything else is really running much as it has been throughout the rest of the phases. I think we can see in this drawing, what I'm saying is that my proposed king's chamber shaft would come to an end and there would be a new shaft established in this sort of position somewhere here, and there would have to be a link between the king's chamber shaft and the new shaft. But I do acknowledge in this drawing, I've drawn it in an incorrect position, but the principle remains the same. It would actually be at a higher level. But as I mentioned, this is not to scale, it's diagrammatic, it's merely representing an idea. I'm assuming that the architect produced drawings and that there were section drawings and plan drawings at each level, and that they specifically decided where the king's chamber was going to be. And it happened to be off-center, off the pyramid. Why, I don't know, because if you look at some of the other pyramids, and I'm stand to be corrected here, but maybe Menkaure or Khafre, the king's chamber is actually below ground, below the bedrock. It's underground, but just slightly underground, and it's centered on the apex of the pyramid. For some unknown reason, this one wasn't done like that. And I don't know for what reason it was, but if we looked at that original section of the existing, we could see that if we took a shaft directly below the king's chamber all the way down, it hits just off the subterranean chamber. So that as a shaft position made sense to me. The fact that they didn't make the king's chamber any higher or any lower is some decision taken by the architect. So I'm saying, you know, the king's chamber shaft was in that position, and in fact it raises another question in why did the king's chamber require a complicated relieving chamber to reduce the forces down on the king's chamber? This doesn't make any sense to me, because the queen's chamber, which is lower down, doesn't have such an elaborate relieving structure above it, but it carries millions of tons more weight. So it makes no sense why the king's chamber had all that elaborate, other than if there was the shaft below the king's chamber. That shaft would have needed protection from the lateral forces, and that's the only reason I can think that the relieving chamber was built. It wasn't just to protect the king's chamber, it was to protect the entire shaft while that shaft was hollow. So that relieving chamber deflected the lateral forces. It's the only thing that makes sense to me, because it's absurd to think that you have to do so much to relieve the weight at that point, yet you do nothing there. You have a pitched ceiling of a couple of stones. So there are a lot of anomalies that like just don't make sense to me. And what I fail to understand is that no one questions it. Okay, these last few drawings are diagrammatic drawings of the final phases of what I'm proposing. They are diagrammatic, are not to scale. But essentially what it is King's Chamber hoisting shaft moving across to a smaller hoisting shaft that's closer to the apex of the pyramid, and then ultimately backfilling. So all the excavated material, the broken blocks were all backfilled into these shafts, and possibly a mortar slurry was poured over them, but essentially I'm saying they were returned to a sort of more solid state. This drawing here is actually a section through the Great Pyramid at a 1 in 500. And I think the purpose of this is just to indicate the length of that King's Chamber shaft versus the length of the Grand Gallery, and also the extended hoisting shafts that would have to go up to get closer to the apex. There are various proposals that have been put down about using the Grand Gallery as a counterweight system to draw blocks up, which I think is very plausible, but it doesn't address or it doesn't make use of the full force of gravity because of the friction. So I think in terms of just efficiency, that a vertical shaft with a free hanging counterweight is going to be so much more efficient than something that has to run on tracks or on rocks or sand or whatever it is. And I'm saying that ramp was probably used to bring the relieving chamber large beams. That's, I think, the way they got them to that level. The other thing I note on this drawing is that there would have been a connection from the King's Chamber offloading area to the next vertical shaft. There would be a loading area there, and that happens to coincide with the recently discovered big void. Whether it is or it's Khufu's tomb, who knows? But in my theory, it's actually a loading chamber. But it formed part of the escape route for those final laborers that were working up to finish the apex. Ultimately, when the shafts had finished their use, they were backfilled, either with the excavated material from the actual shaft that had been dug down to the subterranean chamber, or broken limestone blocks that were casualties of building, because there's always tons of broken bricks left after you finished on a construction site. So instead of having to chuck them away, you actually just filled all the voids up with them and probably put in a mortar slurry over it to hold it together. Okay, in this drawing, I've returned to drawing things to scale. It's a 1 in 100 scale drawing. It is of the relieving chamber of the King's Chamber. The King's Chamber would be down here. It includes the proposed hoisting shaft that I'm proposing, and it furthermore includes the Grand Gallery, Queen's Chamber, and also where I believe there was a corridor that led to an alternate a shaft and a loading area that was just above the Grand Gallery. So many other theories have used the Grand Gallery as a counterweight system. They'd have a counterweight and they would drag the blocks up a ramp and using that. The problem with that is that the Grand Gallery only has a 42-meter length. So it means you'd have to reload your counterweight on numerous times to get the blocks up. Whereas if you're using a shaft that is much longer, you're not going to have to reload your counterweight as much, And also you have the advantage that there's much less friction compared to the friction that you would get on a 26-degree ramp. Yeah. And I'm saying there's possibility that these two could have been combined. You could have used that plus this. Maybe that's how they got these beams up here. Maybe there was this counterweight, and it was linked, and this counterweight was linked to it too. So now you've got, we spoke about earlier how it might not be possible to have a counterweight that was heavy enough to move the 70-ton blocks. But if you've got two counterweight systems working together, it makes your life a lot easier. Plus you'll have some additional labor and that pushing and pulling. So, yeah, and there would have had to be an escape route for the labor, and they would have come down to this loading area. There would have been a corridor that leads towards the relieving chambers. They could link into the Davison's corridor, which comes out somewhere over here. And then they would have gone down the Grand Gallery. The plugging blocks would have been pushed down the ascending corridor, and they would have gone down the other little vertical corridor, and they would have landed in the descending corridor, and they would have ascended in the descending corridor and got out. That's how they got out, the last few workers. I'm going to run through this drawing, the World History Encyclopedia section. I particularly didn't want to use a drawing that I had done, so there's no manipulation of anything lining up so that it suits my theory. But I also want to point out that nowhere have I ever come across a plan view of the top of the relationships of all of these components: the King's Chamber, the Queen's Chamber, the subterranean chamber, the Grand Gallery. I've never seen it from a view of above, so I have to base that on a few assumptions. So the shaft I'm proposing, which I call the King's Chamber shaft, in this drawing it seems to collide with the subterranean chamber, but we're not sure of the depth of where it's actually sitting. Okay, so that's the King's shaft. Then we've got the Grand Gallery here. If we were to use a ramp connected to the counterweight of the King's Chamber shaft, that ramp, an extension of the Grand Gallery roof, as I said, would end up at the perimeter of the pyramid, and that's where the larger blocks that are at the relieving chamber, those would have been hauled up that ramp. The rest of the smaller blocks would go up the King's Chamber shaft, and as the level increased, the shaft would move position and the blocks would come there, and then they'd be taken up that shaft. Once again, if I'm repeating myself, I don't know, but I fail to understand the extent of this relieving chamber, where below that you've got the Queen's Chamber, which has so much more weight on it, yet it doesn't have such an elaborate relieving chamber. And the other thing that I fail to understand again is why they would dig into the bedrock, into this descending passage, if it actually went nowhere. So it must have been part of the design. It must have had a function. And I'm saying again that I think that function was to access the pit of the shaft. And as I just repeat again, I wanted to use somebody else's drawing and not mine to show these relationships. One thing I just wanted to mention was that the Great Pyramid actually has the dimensions of the Earth, particularly the Northern Hemisphere. It's a scale model of the Northern Hemisphere. So it has dimensional consistencies with the Earth itself. It's that related back to the Earth. And I find this issue of using gravity is you now embodying another part of the Earth. You're embodying the gravitational force of the Earth within the structure. It's built by gravity. There will be a follow-up video where I will explain what I believe to be the true purpose of the Great Pyramid of Giza.